Let's briefly go through this paper with Scholaread. How is ChatGPT's behavior changing over time? This paper focuses on the longitudinal drifts of widely used language model services such as GPT 3.5 and GPT-4 over time. The authors argue that monitoring model performance shifts is important for deploying machine learning services in the wild. They offer a large-scale longitudinal dataset of generative LLM services on various evaluation tasks, and they study how to efficiently estimate LLM API performance shifts. The authors focus on 4 LLM tasks frequently studied in performance and safety benchmarks: solving math problems, answering sensitive questions, code generation, and visual reasoning. These tasks are selected for 2 reasons. First, they are diverse tasks frequently used to evaluate LLMs in the literature. Second, they are relatively objective and thus easy to evaluate. For each task, they use one dataset, either sampled from existing datasets or constructed by them for monitoring purposes. The authors acknowledge that using one benchmark dataset does not comprehensively cover a task. Their goal here is not to provide a holistic assessment but to demonstrate that substantial ChatGPT performance drift exists on simple tasks. They are adding more benchmarks in future evaluations as part of a broader, long-term study of LLM service behavior. They cover each task and dataset in detail in the next section. Reading on mobile can be a disaster. But Scholaread app is here to help. Get Scholaread on App Store or Google Play and read smoothly at your fingertips. The authors find that the performance of GPT 3.5 and GPT-4 on the 4 tasks varies over time. They observe that the performance of GPT-4 on the math problem task decreases significantly between March 2023 and June 2023. They also find that the performance of GPT 3.5 on the sensitive question task decreases significantly between March 2023 and June 2023. They argue that these performance drifts are significant and should be monitored over time. The authors propose a method for efficiently estimating LLM API performance shifts. They use a Bayesian hierarchical model to estimate the posterior distribution of the performance shift. They also use a Gaussian process regression model to estimate the performance drift over time. They find that their method is efficient and accurate in estimating the performance shift and drift. The authors conclude that continuous monitoring of LLM quality is important for deploying machine learning services in the wild. They argue that their method for estimating LLM API performance shifts is efficient and accurate. They also argue that their longitudinal dataset of generative LLM services on various evaluation tasks is valuable for future research on LLM service behavior. They suggest that future work should focus on developing more efficient and accurate methods for estimating LLM API performance shifts and drifts. They also suggest that future work should focus on developing more comprehensive benchmarks for evaluating LLMs and on studying the impact of performance drift on downstream applications. Overall, this paper provides valuable insights into the behavior of LLMs over time and highlights the importance of continuous monitoring of LLM quality. The author's longitudinal dataset of generative LLM services on various evaluation tasks and their proposed method for estimating LLM API performance shifts are valuable contributions to the field. However, the authors acknowledge that their study has limitations, such as the use of only one benchmark dataset for each task and the focus on simple tasks. Future work should address these limitations and provide a more comprehensive assessment of LLM service behavior. That's it for today. For a seamless reading experience, download Scholaread. Stay curious. And don't forget to like and subscribe to my channel and press the bell icon to get new video updates.